Today, I'm showing you how to build a fully functional, ESP32 powered vending machine using just cardboard and some smart electronics. Here's what makes this project special. First, it uses a 4x4 matrix keypad for product selection, just like real vending machines. Second, it has intelligent coin detection using an IR sensor with interrupt-based processing. Third, it uses an ultrasonic sensor to actually detect when a product has been dispensed, so the motor stops automatically. Other components used are a 16-channel PWM driver which control up to 16 motors, DRV8833 motor driver, micro N20 geared DC motors and SSD 13060 LED display. And finally, it's powered by an ESP32, which means we could add Wi-Fi connectivity, mobile payments, or artificial intelligence in future upgrades. Let's start with building dispensing mechanism. In the vending world, the design depends on the product, but the most iconic is the spiral coil. It's a simple system where a motor rotates a coil to push the product forward until it drops. For this build, I'm hand-forming the coils from 3mm aluminum craft wire and driving them with N20 gear motors. You can use a bottle cap or 3mm shaft coupler for a more rigid connection. If you're planning on dispensing heavier items, you can easily swap these out for higher torque motors. For this project, I'm testing two different coupling methods. On the first tray, I've gone with a low-cost bottle cap adapter to bridge the motor and the coil. On the second, I'm using a 3mm shaft coupler for a more rigid connection. Now that our motor tray is assembled, we need a way to easily access it for refills. To do this, we're going to build a sliding drawer system using just cardboard and hot glue. Start by cutting 4 cardboard strips to the length of your tray, at a ½ height. Glue 2 of these to each side of the box. Next, cut 2 more strips at 1 inch high and glue them right on top. These will act as the slides for your tray. Now for the rails, mark out where you want your tray to sit on the inside walls, making sure everything is perfectly level. Draw a straight line from front to back on both sides. Just like we did for the tray, glue your ½ inch and 1 inch strips along these lines to create a sturdy ledge. Now place the tray on its tracks and align the opposite wall. Make sure to leave a small 2 mm gap on the sides. This prevents the cardboard from binding while keeping the tray steady. Now that the tray mechanics are ready, let's dive into the electronics. The brain of this build is the ESP32 microcontroller. If you're new to this microcontroller, check out my beginner tutorials and subscribe for more. For the full circuit and code, check video description or visit dappletechie.com. To manage our 6 motors without a mess of wires, we're using this PCA9685PWM driver. But there's a catch: it can't provide enough current for the motors on its own. To avoid frying the board, I'm routing the signal through a DRV8833 motor driver. This gives our N20 motors the power they need, up to 1.5 amps, without risking our controller. To keep our ESP32 pins open for future upgrades like an RFID reader, I'm running everything through an I2C interface. I built a custom common PCB that acts as a hub for power, ground, and multiple I2C devices. For the 4x4 matrix keypad, using a PCF8574 expansion board allows us to use just 2 pins instead of 8. I've also connected the display to our common PCB. This setup keeps the wiring clean and ensures we have plenty of room to add that card reader in a future video. For the screen, you can use any I2C display that fits your build. I'm using the SSD13060 LED. For the dispensing logic, an ultrasonic sensor monitors the drop zone. When the sensor detects an item passing by, it triggers a stop command to the motor, ensuring only one item is dispensed at a time. To detect coins, I'm using a simple IR sensor. We'll take a closer look at coin detector assembly later in this video. For the software, I'm using C++ with the Platform IO extension in Visual Studio Code. I'll be breaking down the full code and logic in an upcoming video, so make sure to subscribe and hit the bell so you don't miss it. Let's move on to the front panel assembly. This houses the keypad, display, and coin slot. I'm also designing this panel with a special section for a card reader, ensuring the machine is ready for a future RFID upgrade. To prevent multi-vending errors, I've added an ultrasonic sensor for real-time drop detection. The ESP32 monitors the sensor's distance data. Once a product is detected in the delivery path, the system immediately stops the power to the motor. To eliminate blind spots at the edges of the tray, I've engineered a conical cardboard funnel. This physical constraint directs every item into the sensor's primary detection zone, ensuring 100% verification accuracy. Next, let's look at the coin detector assembly. The coin mechanism uses a ramp featuring a precision trapdoor. This gap is sized so that smaller coins fall through immediately, while larger coins bridge the opening and continue rolling into the coin box. At the exit of the ramp, I've installed an infrared sensor. When a coin passes through and breaks the IR beam, it sends an interrupt signal to the microcontroller. This instantly updates the display to select item and prepares the keypad for the user's input. Now that the main features are functional, Let's wrap up the build by mounting the exterior panels, doors and finishing the machine's housing. Now that the assembly is finished and the code is live, we are officially ready for the final demonstration. Watch how the system detects the coin, triggers the interrupt, and enables the keypad for a selection. It's been an incredible journey turning simple cardboard into a smart, microcontroller-powered machine. Visit dappletechie.com for a full breakdown of the project's architecture and code. Thanks for watching. For the next phase of this project, we'll be implementing a card reader and developing a voice-activated interface using custom AI agents. Subscribe and press the bell icon to stay updated on the latest progress. I'll see you in the next one. Thanks for watching.